So welcome athletes to your first video. For Unit 1 we're going to be solving linear systems, and there's 3 different strategies that you're going to be looking at, and the first one we're going to be doing is solving by graphing. So what does it actually mean to solve a linear system? Well, that actually means that you are determining the point of intersection. And POI is what we can use for short for point of intersection. So we're going to go through some of the steps, and again, this is just for solving by graphing. And so the first step that you're going to be following is that you need to write both of your equations. So it's possible that one of them could be in standard form. You need to write both of them in y equals mx plus b form. The next step is you're going to just look at one equation at a time, and the first equation you're going to plot the y-intercept, and from that y-intercept you're going to use the slope, and you're going to rise over run from that y-intercept, and then you're going to plot another point. Once you've plotted that point, you're going to connect those dots, draw the line, and then label the line. You're going to repeat those same steps from 2 to 4 for the second equation. So now at this point you should have 2 lines graphed and labeled. Once you've graphed both of them, then you're going to state the coordinates, which should be x comma y, for the point of intersection. So with those steps, you want to make sure that they end up on your summary sheet. And now we're going to do an example, which should also be able to fit there. So our first step was to make sure both equations are in y equals mx plus b form. First one is done for us. And so now this one is not, it's in standard form, so we need to change it. Y equals mx plus b form means that the y needs to stay on the left side and everything else should be on the right hand side. So that means our 2x should move over and our 6 needs to move over. You need to remember opposite operations. So if we leave y, it's positive y, so that stays as is. And when we bring the 2x over, it's positive 2x in front. So when we bring it to the other side, it's negative 2x. And when we bring the plus 6 to the other side, it's minus 6, because you must do the opposite operation. So now we have our 2 equations in standard form. So we start with our first one, and we have to plot our y-intercept, which is negative 1. So when we go to our graph, here's x and y. It's very important to label those. Your y-intercept is negative 1, and then your slope is this number here, but it doesn't have a rise and a run. So when you have a whole number like that, every whole number can be put over 1, and now we have a rise and a run. So from this point, we have to rise 3, 1, 2, 3, and run 1. And we could do that a few times. Rise 3, run 1, and then we can take a line, and we can connect the dots. And once you have those dots connected, you can label. So this is y equals 3x minus 1. And right now I'm going to extend this line so that it takes over the whole, almost the whole graph. And then you do this same thing for the other equation. And there's the second line already done. And so the last step that you had to do was to state where the point of intersection was. So I'm going to do this in red. So you should be saying, therefore, the point of intersection is, and when you read from the graph, here's our x-axis. So here is where the point of intersection is, which is negative 1, comma, negative 4. So negative 1, comma, negative 4 is the point of intersection. And there you have it. The only thing I would like you to think about is to think about why this method may not be the best method to use every single time. And we can take that up in class. So make sure this is all written down and you bring to class tomorrow with any questions that you have. Thanks for joining, and see you in class. Bye.